They're on that only. Now see here, what you have to do is, in this case, when your f dash x is negative, means the function is decreasing between -2 and 0.
Okay.
So this will,
like it's actually
it's decreasing between -2 and 0. Positive means it's concave up. Your second order derivative is positive, means concave up. So it's passing. So this is from -2 to 0.
Yeah.
So -2 to 0 is decreasing and it's concave up.
Why aren't you going through -2?
You can go through -2 also. Doesn't matter. Doesn't matter. If you just roughly have to draw a curve. Now it is passing.
You just said it's concave up.
Concave up. This is concave up. Definitely this is
How is
concave.
it concave up?
This is concave up. It's cup. It's opening up. This concave up. This concave up. Okay. Now 0 minus 1. So the point is 0 minus 1. Over here the slope is 0. Means here the slope is 0. Yeah, it became flat. And it's positive. Yeah, it is positive. It's concave up.
Concave
It is still concave up.
So just
It is concave up. Yeah. Now, between 0 and 1, its derivative is positive, means it's increasing, and it's concave up. It's increasing and it's concave up. So it's increasing and it's concave up till this point.
Why do it still that point?
It's given no 1, 2 next point. And just give passing. You have to go there basically. Now, over here it's positive and 0. The slope is 0.
Yeah.
Means when the second order derivative is 0, it's a point of inflection.
Shit.
When a second order derivative is 0, it's a point of inflection. So this is a point of inflection.
Yeah.
Means the curvature will change after this. So this is concave up. After this it will go concave down. See now, it became negative. So it's increasing. Derivative is positive, means it's increasing. And how is it going?
Down.
Down. So from 1 to 2.
Draw it like that down.
Yeah. So it's going increasing and concave down. Like this.
Where are the conditions for everything like that?
So these notes are in derivative, sine and second order derivative. So if you see over there, see local maximum. What are the
Can I just
conditions?
go through that right now?
Yes, please go through them. Prove anything is to prove anything is local maximum. What you have to do is first order derivative is equal to 0, and you make boxes and you get your sign diagram for the first order derivative. If it's plus minus, then it's a maximum.
I don't do that.
Huh?
I do the box.
Now box thing, same thing now, but box may first you'll get positive and negative.
I plug the values.
Yes, plug the
Same
values and you'll get a value positive, negative you to get. Box or line neutral is the same thing. Or if you don't want to do this, local maximum, the other way of doing it is your first order derivative should be 0 and your second order derivative should be negative. They can ask you, prove it using the second order derivative.
Oh.
Because it will be concave down. Yeah, concave
So
down.
the second order is less than 0, meaning it's negative, then
It's concave down. So it is maximum now.
So we think of that as concave.
Concavity, yeah. When your second order derivative is negative, it's concave down, so it will be maximum. Local minimum, first order derivative is equal to 0.
That makes sense.
And the first order derivative sign, if you're drawing boxes, you should get minus first,
And then
0
plus.
and plus.
But sir,
This is for increasing, decreasing.
Yeah,
but sir,
decreasing and increasing.
Yeah.
So left to right, decreasing first, local minimum.
Two things. First of all, this is obviously at that local maximum point, right?
Yeah.
And so, but like the second order, so does that mean that the second order derivative at any point in the
At
graph,
that point only.
no, at any point in the graph except the minimum or maximum will be equal to 0?
No.
Then will be negative.
Second
or
order,
positive?
second
Oh,
order.
sorry. And both of
And
those
both
have to be
conditions have to be satisfied.
true. Okay, sorry, my mistake.
First order derivative 0 and second order derivative is positive. At that point, same point.
That makes sense because
Positive
maximum
is-
is increasing.
yeah.
And like this.
It's a cup.
Cup.
Concave up.
Yeah.
Concave up. Cup
Concave
up.
up.
Yeah.
Concave up. Oh, yeah.
Point of inflection. For point of inflection, the second order derivative is equal to 0. for any point of inflection second order derivative, and there should be a sign change for the second order derivative. Either should be plus minus or minus plus. When you draw
How do you
boxes,
check for that?
same thing, you take a point before, after.
Substitute the second order.
Second order derivative. Yeah. After doing that, you have to put that answer in the first order derivative. If you put that answer in the first order derivative, and if it's equal to 0, it's a horizontal point of inflection. Or it is an oblique point of inflection. We have done this over here. I'll tell you 1 second.
No, we've done till lesson 8 now.
Okay, now see, determine all the stationary points and all points of inflection.
I don't know the difference.
Stationary point
Maximum and like point of inflection.
where the curvature changes. Now when you're doing a stationary point, you take the first order derivative, that's 3x squared plus 6x, make it equal to 0, solve for the values of x, put in the values in a box or a number line, it won't matter. Take a value before this, so I took minus 3, I got a value of 9, so positive. I took minus 1, I put a value inside, I got negative. So negative, positive, negative, positive. So if this is positive and negative, what does it mean? Max, positive and negative. It's going. So positive means it's increasing and then it's decreasing. Huh? So it's a local max at minus 2. The negative positive means what? Local minimum.
This is fine. I'm saying at that point.
Points of inflection, what do? You take the function, you take the derivative, take the second order derivative, make it equal to 0, solve it, put that in a box or a number line, take a value before minus 1,
And substitute
substitute a second order derivative, it's negative, positive, there should be a sign change. So there's a confirmed point of inflection at x is equal to minus 1. Now to classify it, you put it back in the first order derivative. So you put this value in the first order derivative. When you put this value in the first order derivative, this is what you get. You get minus 3. Means it's a negative sloping point of inflection, which your curve would be like this.
So if it asks you to
Sketch it, yeah, this will be a sketch. Yeah, this will be a negative sloping point of
because it's
inflection.
not stationary.
Yeah. Whenever they say the gradient of the curve is maximum, whenever they say the gradient of the curve, listen, this is important. Huh? Whenever they say the gradient of the curve is maximum at B, it means that B is a point of inflection.
Oh.
Remember, at point of inflection, the slopes are ultimate. So at B, this is positive slope, so this is maximum slope.
So when the
At D, this is a minimum slope. That's what they've given you. Minimum value at B means that's a point of inflection. But for the horizontal point of inflection, this is concave up,
Yeah.
and after this point is getting concave down. So
That's
this is
so
a
much smarter.
horizontal point of inflection.
It's so much easier.
What we did is look from which is a point. This is a point of inflection. Point of inflection will always become the turning point. Correct?
What's
This-
in the first order?
I am sketching the first order derivative, obviously. I am sketching the first order derivative. Okay, fine. The point of inflection will become what? Acha, this is increasing or decreasing?
Increasing.
When
So
the-
it'll be maximum.
The slope would be positive. Then here, what does it become? Zero. Because point of inflection, point of inflection, sorry, this will be positive. At B, it's positive still. Okay, after that, it becomes what? After B,
Negative.
what does it become? It becomes
0.
the slope remains positive. See, the slope, think like this. Listen, the slope is positive. Correct? Here the slope becomes maximum, and the slope is still positive, and the slope then becomes what? 0. So slope is what? Positive, maximum. You can write anywhere, and the slope becomes what? 0, like this. The slope is positive. Here it becomes maximum. Remember, at point of inflection, there will be a turning point. 0. Now here the slope become, because this became the horizontal line, this becomes 0. Okay.
So that's an x-intercept.
Now this one, what is happening is
Negative.
negative,
So it's a minimum.
negative,
नीचे जाएगा.
0,
नीचे जाएगा.
negative. This will become the, remember the point of inflection will become the turning point. Just write it down.
Turning point. What's turning point?
Arey, turn, turning point. So turning, but
So, but aren't you, so I'm very confused because aren't you supposed to do the negative slope like on D? But it's like not
D,
corresponding,
listen,
not corresponding.
this is negative, this is negative, here, and this will come like this.
So actually,
Remember your point of inflection
Oh, is it?
is the turning point, it's the horizontal point of inflection. So this is your graph for the derivative.
so
So you're following that.
I'm thinking very simply. Whenever your derivative is positive, the graph is above the x-axis, the derivative graph. At the point of inflection, there's a turning point. At the maximum minimum, there's a intercept. Again, there's a turning point. Again, there's a turning point. So wherever this derivative is negative, it's below. So at point D, the graph is below. Wherever the slopes are negative, the derivative graph is below the axis. Now see, here there's a maximum in fx.
which means in f.
In your first order derivative is what? Intercept. Now, if I take the second order derivative, it will be negative.
So
The
it can
slope
be
is
anything.
negative, no? It can be anything.
Anything.
It can also cross like this, no? That will be positive.
So sir, just coincidentally, it's a point.
Because generally you have to judge the point of inflection. So for the second, so the point of inflection for here would be somewhere here. This here somewhere. C is not a point of, C is point of inflection will be somewhere there.
So it's nothing.
It's nothing. Yeah, C is just any random point.
And even
Are you following that?
yeah,
Huh.
just assume that this is a turning point. That's a turning point.
Yeah, that's a turning point.
So, but I also have a question. So it says negative 0, negative. So if it's negative, that's what like negative 0.
But negative, this is negative here. It's negative is below the x-axis.
I thought negative meant like
Negative meant when you're looking at the curve, but you're looking at the sign of the derivative.
Or sir,
This value, so the negative for the derivative graph is below the x-axis. No, you're not looking at the direction in which the curve is
y
going.
values don't matter.
Y values give you the slope directly.
No. I mean, like if my minimum is there or something.
Okay, now listen to this carefully. You have to find a derivative graph of this. So what you do is you'll make a box. You'll make a box. Okay? You'll make a box. You'll take the points. The point of inflection is here. So let's call it F. F, A, B, C, D. You'll A, correct? You'll take B. You'll take F. C I'm not taking. I don't want C because this is a random point given from the question. Huh? You'll take D. Then you can take E. What is the slope? What is the slope at A? What is the slope at B?
No.
0.
What is slope at F?
Positive.
Correct. What is slope at D?
0. And negative.
Negative. Now, whenever your f dash x is negative, na, means your graph will be below. So that means that B is 0. At D is 0, first you mark the zeros. Okay. Now, whenever it's negative, no, you write below x-axis. Means the graph is below x-axis. You don't look at the way the graph is going. The graph is below x-axis. 0 means it cuts it. Now from below it's coming above. And then 0, then it's going below.
That's more.
So below.
Crazy.
Now it's going above. Now above where it's going and then it's going below. It has to turn. So below. End of the story. Remember, whenever you have a stationary point of inflection, the graph of the derivative will touch the x-axis.
Okay.
It will be a turning point.
But how do I know if it's minimum or maximum?
That you have to see the sign. Na? Whether basically you have to think whether it's above or below. You think how the function is turning. You start doing it, you'll get a hang of it. Listen. Look, what do we have?